In this video, we are going to talk about the ideal gas. Now, this is a very important concept once we progress with our topic in thermodynamics. So, ideal gas is ideal in the sense that it conforms to the gas laws. Okay, so what are these? What are these gas laws? No? First gas law that we are going to talk about is about Boyle's law. Okay, so Boyle's law is formulated by Robert Boyle, and he formulated that if temperature is constant, okay, if temperature of a given gas is constant, then the volume will vary inversely with the absolute pressure. Okay, volume will vary inversely with the absolute pressure. So that means that pressure times volume is equal to C. Okay, when you say varies inversely, it means that if your volume would go up, then your pressure would go down. Okay, and also if your volume would go down, then your pressure would go up. So you have PV is equal to C, or if we will translate that into 2 points, no, that will be P1 V1 is equal to P sub 2 V sub 2. Okay, we go to another gas law. Another gas law is by Joseph Louis Gay-Lussac, or known as Charles' law. So this Charles' law is divided into two. The first one is if pressure of a gas is constant, then the volume will vary directly with the absolute temperature. Okay, so it means that if volume goes up, then temperature will also go up. So we have V varies directly with T, or V over T would be equal to C. Okay, so we have V1 over T1 is equal to V sub 2 over T sub 2. The next is if the volume of a particular gas is held constant, then the pressure will vary directly with temperature. Okay, so pressure will vary directly with temperature, and we'll have P over T is equal to C, and therefore P1 over T1 is equal to P sub 2 over T sub 2. Okay, so next is the equation of state, or the characteristic equation of a perfect gas. So this is formulated by combining the gas laws. So combining Charles' law and Boyle's law, we will arrive at P1 V1 over T1 is equal to P sub 2 V sub 2 over T sub 2. Okay, and PV over T is equal to C, or is equal to M times R. Now, what is R? R there is called your specific gas constant. Specific gas constant. So, for every gas, we have a specific gas constant. So, PV over T is equal to MR, or we'll have PV is equal to MRT. We can also express this formula as P is equal to rho RT. Okay, since mass over volume is density. Okay, so remember those three formulas in dealing with problems for ideal gas. Now, let's have some review problems here. Problem number 1, an automobile tire is inflated to 32 psig. So, be mindful of the pressure here. It's in gauge pressure at 50 degrees. After being driven, the temperature rises to 75 degrees. Now, determine the final gauge pressure, assuming the volume remains constant. This is a board exam problem. So, the first state is P1 is equal to 32 psig. Now, for it to become absolute pressure, we need to add 14.7. So adding 14.7 would result to 46.7 psia. So that is already absolute. Next, we have temperature is equal to 50 degrees Fahrenheit. So we need to add 460 to make it Rankine. Okay, so remember that temperature and pressure in dealing with this problem should always be absolute. If you apply the formulas and your temperature is not absolute, then you will get the incorrect answer. So we have 510 degrees degree Rankine, and then after being driven, so here because the tire is driven, of course, heat was applied. So the temperature rises to 75 degrees. So T2 is 75 degrees Fahrenheit. So we add 460, and the result is equal to 535 degree Rankine. Okay. Now, since the volume is constant, volume here is constant, so therefore the formula that we are going to apply is T1 over T1 is equal to P sub 2 over P sub 2. And we will solve for P sub 2. So therefore that would be equal to T1 times T2 all over T1. So let's input the given. We have P sub 1 is equal to 46.7 psi. T sub 2 is 535 degree Rankine. And T sub 1 is 510 degree Rankine. So let's get our calculator. Let's do 46.7 times 535, then divide by 510. So we'll have 48.99 psia. But the problem requires us to get the pressure, the final pressure in gauge. So we will now subtract 14.7. So get our calculator again. Let's subtract 14.7 from our answer, and the answer is 34.29 psig. 34.29 psi gauge. Okay, another problem. Problem number 2, we have 400 cubic meters of gas at 700 millimeters of mercury absolute. So we don't have any problem here because it's already in absolute pressure, and 18 degree centigrade undergoes a process. So there's always a process, okay, that would change the pressure or whatever quantity given in the problem. So in this case, the pressure becomes 760 millimeters of mercury and the temperature of 0 degrees. So find the final volume of the gas. So let's just write the given first. We have V1. V1 volume is equal to 400 cubic meters. And then P1 is equal to 740 millimeters of mercury. And then T1, we have 18 degrees. So we need to add 273 to make it Kelvin. Let's get our calculator. 18 plus 273. We have 291 Kelvin. And then we have P sub 2 is equal to 760 millimeters of mercury. And temperature sub 2, that is 0. So if we add 273, then we'll simply get 273 Kelvin. Now here we will apply the combined gas law. P1V1 over T1 is equal to P2V2 all over T2. And from this, we can solve for V sub 2. And V sub 2 would be equal to P1V1 times T2 all over P2 times P sub 1. Okay, so we will solve it here. We have P1 is equal to 740 millimeters of mercury, then multiply by V1 for 100 cubic meters. Okay, and then T sub 2, 273, P sub 2, 760 millimeters of mercury, and P sub 1 is 291 Kelvin. Okay, so let's cancel the unit first. The units, millimeters of mercury cancels out, Kelvin cancels out, final unit is in cubic meter. So we have 740 times 400 times 273, and then let's divide that by 760 times 291. So the answer is 365.38. 365.38 cubic meters. Okay, so this is the final answer to our problem. So next, problem number 3, we have a 10 cubic foot tank contains a gas at a pressure of 500 psia. So here, because it's a tank, because our given involves a tank, then therefore volume, we can assume that volume, or we will have volume as constant, no? So since this is a gas, and a gas only takes the shape of its container, so therefore the gas will always have a volume of 10 cubic feet. So 10 cubic feet. Pressure 500 psia. Temperature 85 degrees Fahrenheit. So 85 plus 460. 85 plus 460, 545. 545 degree Rankine. And the weight of 25 pounds. Okay? So we have a weight of 25 pounds. So this is pound force because it's a weight. Part of the gas was discharged. And the temperature and pressure changed to 70 degrees Fahrenheit and 300 psi A. So we have P sub 2 is equal to 300 psia A. And T sub 2 is now 70 degrees Fahrenheit. So we'll add 460. So that would be equal to 530 degree Rankine. Okay, heat was applied and the temperature was back to 85 degrees. So it means to say P1, we have state 1 of the gas, second state of the gas, because some part of the gas was released, and we have state 3, where the temperature was back to 85 degrees. So 545 degree Rankine. Find the final weight, volume, and pressure of the gas. This is a board exam problem. So here we can see, if you are observing, we can already answer the volume because this is a tank. So therefore, V sub 3, okay, final volume, but there's no really final volume because it's a tank. It does not change, no? So that's the answer already. Let's just say V sub 3 is equal to 10 cubic foot. Okay? Next, the final weight. So before we can solve for the final weight, we need to find out what is the mass, equivalent mass of this 25 pound force. Okay? So we have weight is equal to 25 pound force, and we know that weight is equal to mass times G over K. Therefore, mass is equal to WK over G. So we have 25 pound force. So let's say we use 1 as our K. 1 slug. So therefore, the unit that we will solve the mass in is in slug. Okay. So this is the initial mass. Let's say that is mass sub 1. So 1 slug feet over pound force second square all over g. Let's assume 32.174 feet per second square. So here, feet per second square will cancel out, pound force will cancel out, and the final unit for our mass is in slug. Okay, so let's say mass sub 1. Let's get our calculator. We have 25 divided by 32.174. So 0.777. 0.77 slugs. Now, it says in the problem that a part of the gas was discharged and you have the resulting pressure and temperature. Okay, so we can use the equation of state. We have PV is equal to MRT. Okay, so in this case we'll use P2V2 is equal to MRT2, and we can solve for the mass, no, the mass sub 2. Okay, so but to do that we must first know what is the specific gas constant of this particular gas. Okay, R. So if we will we can get that from our initial condition, because we have P1 V1 and we also have the temperature 1. Okay, P1 V1 is equal to MR T1. Okay, so therefore R would be equal to, this is also M1. Okay, R would be equal to T1 V1 over M sub 1 T sub 1. Okay, we don't actually need to solve for this. We can just go ahead and input this with this equation. Okay, so if we will input that, we'll have P2V2 is equal to M sub 2. Let's mark this as mass sub 2. And then R is equal to P1V1 over M1 T sub 1 times T sub 2. Okay? So from this, we can already solve M sub 2. And M sub 2 is clearly P2V2 all over T2 over P1V1 over M sub 1 T sub 1. Let's just fix this formula a bit. Okay, let's get my eraser. Let's just fix this formula so that it won't be hard for us to input the given and use the calculator. Okay, so we have P2V2. This will be in the numerator, and what's also in the numerator is also M1 and T sub 1. Okay, you already know that because this will be this will be a reciprocal once it goes to the numerator. Okay, so P2V2 times M1 T1 all over P1 V1 times T sub 2. Okay, so we'll have M sub 2 is equal to, so let's change our pen. P sub 2 is equal to, let's go back to our given. P sub 2 is equal to 300 psia. V sub 2 is it's a tank, so therefore it's still 10 cubic feet. Mass sub 1 is equal to 0.77 slugs. Okay, T sub 1 is equal to, sorry, I forgot. T sub 1 is equal to 545 degree Rankine. And then we have over P1 V1 times T2. Okay, So P sub 1 is equal to 500 psia. V1 is still 10 cubic feet. Okay, and finally T sub 2 is equal to 530 degree Rankine. Okay, so the units that would be cancelled, let's cancel the units first. Rankine is cancelled, cubic feet is cancelled, actually 10 is also cancelled, psi is cancelled. So the final unit here is slug. So m sub 2 is equal to, let's get our calculator. We have 300 times 0.77 777 times 545, and then let's divide that by 50 times 530. Okay, oh sorry, there was a mistake in the calculator in my operation. So 300 again times 0.77 times 545, and we will divide that answer by 50 times 530. So the answer is 4.79 slugs. Okay, let's check our given first, no? So I have here P1. So I remember P1 is supposed to be 500. Sorry about that. So this is supposed to be 500, and we will have a different answer then. Let's just correct this, okay? So you have to be careful when getting your given, or else we'll have an incorrect answer. So 300 times 0.77 times 545. Siguro na-notice nyo rin, no? Why did I choose 50 as my P sub 1, no? Supposed to be it's 500. So times 530. Let's divide that. So we have 0.479. 0.479 slugs. Okay? If in case na ang pinapahanap, no, the unit for mass that is required in the problem is in pound mass, that could also happen. We will simply convert slug to pound mass by multiplying 0.479 by 32.174, because that's the conversion, no? So we have 15.41 pound mass. Okay, just in the case that in the problem you are required to solve in pound mass. So we have slugs and pound mass. So last, go back to our problem number 3. So we have the final weight. Oh, weight pa lang hinahanap class. So it's not the mass. So we have to solve in pound force. Okay, nawala ako doon. I'm sorry. So let's just go to the next board, no? We have our final mass, m sub 2, is equal to 0.477 slug. Now, if we had to solve for the weight, then 0.477, so that's mass, okay, slugs. Then we have to m times g, so 32.174 feet per second square, and we'll use 1 as our k, slug feet over pound force second square. Okay, so what will be cancelled here? You can cancel feet per second square. We'll also cancel slug, and the final unit is in pound force. So this is actually what we have done also when we have converted to we multiplied 32.174. So the answer will also be 15.41. But 15.41 this is in pound force, no? So sir, what about the answer that's equal to 15.41 pound mass? So if we will not convert, if we will translate, or we will also solve for the weight. If we start at 15.41 pound mass, okay, of course we have to multiply 32.174 feet per second square as our gravitational acceleration, but the k here is also 32.174. Okay, so this is pound mass feet over pound force second square. So in that case, no, look at the units. Feet per second square will cancel out. Pound mass will also cancel out. Final unit is in pound force. So 32.174 will also cancel out itself. And weight 2 is also 15.41 pound force. Okay? So the weight is the same whether regardless of your unit in mass. So we have the weight, we have the volume, and the final unknown here is the pressure. Okay, the final pressure of the gas. Of course, the final weight of the gas is already W sub 2. Okay, this is already the final weight because from state 2 to state 3, there's no longer change in the weight of the gas. Okay, so from point 2, okay, from point 2 to point 3, we have pressure, temperature, and from point 2 to point 3, our volume is again constant. So the formula that we are going to use is P2 over T2. P2 over T2 is equal to P3 over T sub 3. So from this, we'll have P sub 3 is equal to P sub 2 times T sub 3 over T sub 2. Okay? So, simpleng ano na lang yan guys? Simpleng solution na lang, no? P sub 2 is 300. Baka magkamali ulit tayo ng pag-input. Let's be careful. T sub 3 sabi bumalik, no? When heat was applied, temperature returned to the original temperature, which is 545 degree Rankine. And T sub 2 is equal to, let me go back because I don't want to miss the given, 530 degree Rankine. Okay, so Rankine cancels out. The final unit is in psi. So again, let's get our calculator for the last time. We have 300 times 545, then divide that by 530, and the answer is 308.49.